all, today let's discuss about question number 60, K 2022 Chemistry. Here the question is, a certain wave function for the hydrogen-like atom is given by psi r theta phi is equal to root 2 divided by 81 into root of pi into z divided by a0 whole raised to 5 by 2 into 6 minus zr divided by 6 a0 into r into e raised to minus zr divided by 3a0 into cos theta. We have to find out the number of nodes in this wave function. First of all, we have to understand, for hydrogen-like atoms, there are two types of nodes. First one is radial node. Second one is angular nodes. And before discussing about this question, first let's discuss about radial nodes and angular nodes. Radial node is nothing but the spherical surface region where the probability of finding an electron is 0. And the number of radial nodes can be calculated as n minus L minus 1, where n is principal quantum number and L is azimuthal quantum number. Okay, so if you are taking one s orbital, this n minus L minus 1 will be equal to 1 minus, for s orbital, L value is equal to 0. So 1 minus 0 minus 1, this is equal to 0. Therefore, for 1s orbital, there will not be any nodes. If you are calculating the same for 3s orbital, n minus L minus 1 is equal to 3 minus 0 minus 1 is equal to 2. These here in this picture you can see there are two white color regions, that these are the nodes of 3s orbital. Now let's talk about angular nodes. Angular nodes are nothing but the planes or planar areas around the nucleus where the probability of finding an electron is 0. Number of angular nodes can be calculated using the azimuthal quantum number. If you are taking 2px orbital, here you can see a plane which is grey in color, which is going in between these two lobes. So there one node will be present, that is called the angular node. For 2px orbital, angular node will be equal to 1 because L value is equal to 1. And total number of nodes will be equal to sum of radial node plus angular node. If it is sum, we can write like n minus L minus 1, this is radial node, plus L, this is angular node. So the total will be n minus 1. So total number of nodes is equal to n minus 1. Now let's go to the question number 60. Before that, we have to understand one more thing. For hydrogen-like atoms, wave function in spherical polar coordinates can be written as the product of radial wave function into angular wave function. Here, this RNLR, this is the radial wave function, and YLML theta phi, this is the angular wave function, where this RNLR is proportional to 2ZR divided by NA0 the whole raised to L into E raised to minus ZR divided by NA0 into plus L 2L plus 1. This is Laguerre polynomial. Laguerre polynomial. Now, if you are comparing This is the wave function given in the question. If you are comparing this equation 1 and 2, you can see that n value or principal quantum number value is 3. That means n is equal to 3. Using this n value, we can directly calculate total number of nodes. Total number of nodes is equal to n minus 1. That is equal to 3 minus 1. This is equal to 2. So total number of nodes is equal to 2. If you want to calculate angular node and radial node separately, you have to use the equations like n minus L minus 1 for radial node and L for angular node. And you have to add this together to get the total number of nodes, or else you can calculate it directly as n minus 1 is equal to 2. So the answer of this question, total number of nodes is equal to 2. For further reference, you can go and check this NPTEL video. Thank you.